Welcome to our AHT Expert Talk, today with the topic Remote CO2 Systems in Commercial Refrigeration. I'm joined today by Hermanus and Günther. Both are working in the business development team at AHT Cooling Systems. So to get started, Günther, can you give us a brief explanation on how a remote CO2 system works?
For sure. Basically, a remote CO2 system works like every other refrigerant system. Of course, with higher pressures due to the low critical point that CO2 has. So we still need the four main components like the compressor, the gas cooler, because it's a gas cooler because we're above the critical point, so it's no longer a condenser. We need an expansion valve and evaporator in the multi-deck, for example, in the cabinets or in the cold room. Okay. So these are the four main features. Then the special thing on a CO2 remote system is also that you have two suction lines. Mm-hmm. So you have one suction line for medium temperature, for example, and one for low temperature, and one combined liquid line.
Okay. So, Hermanus, what kind of other components do I need to have a remote CO2 system running?
Yeah, so like Günther already said, the compressor rack, of course, and for a remote system, it's the special thing that you have a central rack. So not in every cabinet you have like our own refrigeration cycle, but a central rack with a lower stage for lower temperature and medium temperature. And of course, also after the gas cooler, you need a high pressure a valve to lower your pressure before you go into your liquid receiver.
Okay.
And then in this liquid receiver, because you have a mixture in there, you also need a medium pressure valve to control it and also bypass it to your medium temperature compressors.
Okay. For which stores is it actually best used for?
This is a great question because there is no limit in principle. Mm-hmm. So you can use it for very small or even tiny stores, so like gas stations or small convenience stores, up to supermarkets and even hypermarkets. Okay. So there is no limit for CO2, but mainly it's used for the bigger stores for the moment. But for sure, especially in the Daikin AHT group, we also have applications or solutions for the small stores, like our condensing units.
Okay. Hermanus, if you think about the remote CO2 system compared to other systems, what kind of advantages would you say does a remote CO2 have compared to HFC systems or other ones?
For me, the biggest advantage is it's a future-proof system. With all the regulations changing, so F-gas regulations, PFAS, it's still proposal, but still it's expected to be changes. A lot of refrigerants, older refrigerants which we're used to, will be banned, will get more expensive. With CO2 system, since it's the reference point, you are sure of your system. Okay. So that's the biggest advantage for me.
Now we've heard about the advantages. Günther, what would you say are the challenges with remote CO2 systems?
Yeah, for sure we need to change a bit our mind and to get used to this kind of system because it's a high pressure system. So we need special pipes, for example. The evaporator need to be for a higher pressure proofed, more or less. So first of all, you need to train your service personnel. You need to train the staff in the office as well, the project managers and so on. So these are the main challenges that I see ahead.
Okay. So we have already heard about a couple of challenges. How's the regulatory landscape there? Are there like any safety preconditions that I need to fulfill when I want to install a system like that?
This always depends on the room sizes, for example. So if you have too much refrigerant in your system, then you need some kind of gas sensors, for example, for cold rooms. This could also happen in the sales area, but only if you have very small and tiny stores and with big refrigerant charges.
Okay.
So it always depends on the system.
Okay. Yeah. So when we talk about remote CO2 systems, we have basically the refrigerant in the pipes. And if there is any kind of malfunction or any dysfunction, basically the whole system stops. Is there any preconditions or pre-safety measures that I can take to avoid that kind of errors?
For sure, yes. So we have a high focus on monitoring of our systems, and because of all the monitoring, you can see all the pressures and temperatures and stuff like that. And if you see beforehand something is wrong there, you can already send the technicians there to check the whole system, to check for leakage or whatsoever. Another thing is also the compressor racks. They have multiple compressors, so if one fails, there is still some other compressors for redundancy to take over the job. Let's say it like that. Yeah.
Okay. We already know that remote CO2 is quite an established system. But let's take a look into the future and to the developments that are coming. What can you see there on the horizon?
Yeah, you will for sure know that we are already looking for energy efficient systems. So energy consumption is always a key topic for our customers, no matter of the sizes of the supermarkets or stores. So to have a system that is really looking on the energy consumption is the key factor. So in the pipeline more or less, or what is coming more and more are semi-flooded technologies more or less, so that you use the complete space of the evaporator and limit the superheat a bit. So normally we're talking about superheat from 6 to 8 Kelvin, and on a semi-flooded conditions we're talking about 0 to 1K superheat only. So this helps the system to be more energy efficient because you can use more of the surface of the evaporator, for example.
Okay. Now, if we look at a traditional store setup, what are usually the components that I can equip with the remote CO2 system? And are there any limitations, any kind of cabinets that I cannot connect to it?
Actually, the portfolio which is available nowadays is already quite broad. So, of course, one of the most important ones is the wall cabinets, multi-depth, in my opinion. But also every store has cold rooms. There are many cold room solutions. But also if you look more in high-end supermarkets that serve over counters, it's possible semi-vertical cabinets. So actually, it's already a huge portfolio. Yeah.
Okay, so basically, when I choose a remote CO2 system, I can really cover everything that I need in my store. Okay, that's good. Now, is there any situation where you would not recommend a remote CO2 system for a shop owner?
This is a good question now. To be honest, no, I could not imagine any case where CO2 wouldn't fit the customer needs. For sure, there might be some in whatever area. Maybe if we talk about different continents, for example, maybe in Africa or in South America, it will not be the best solution. But for sure, it can also work there under these conditions.
Okay. So the conditions you mentioned in these countries, why are they not really suitable for remote CO2 systems?
Because CO2 has, as mentioned before, already a very high pressure. So, and if the system stands still then the pressure even rises higher. And at a certain moment, the safety valve will blow off. And as a customer, you don't like to lose the complete refrigerant of your system, because then the system cannot start anymore. And due to this, in very hot conditions, in different regions, also with the electricity problems that they might have there, it could happen that the refrigerant is gone, and then for sure you need or would like to have a different solution than CO2.
Okay, so when I have a blackout, for example, the whole refrigerant is basically blown off out of the system. So what does it mean when I need to restart a system like that? Do I need a service technician for that? And what are his duties to do in order to get the system restarted?
I would say yes. I would always recommend to send at least a technician. And of course, since you lost refrigerant, you need to refill it. I would also always check electricity supply if it's still valid. I think there were some examples in Germany where there was a loss of electricity, and then a lot of not only refrigeration system but also a lot of other systems just went down. So electricity supply is for me an important thing. And then, like I said, check together with the monitoring system if your temperatures and pressures are still in a good range.
Okay. What we see more often is standardization. So really supermarkets or food retailers in general, they want to have a standardized concept for their shop. Is there anything in the pipeline where you would say this is a standardized system, and what is the difference between a standardized system and a non-standardized system?
There are for sure some standardized systems that we have also in our portfolio, but this does not limit us on these kind of systems. So you can always extend them or reduce the systems. So there are, again, no limits for our systems.
Yeah, in my opinion, I'm working on a lot of different projects, so I wouldn't call something standard, to be honest. It's more the variable. You can do like a lot of different things, so that's a big pro, I think. Okay.
How do you see the topic with skilled labor shortage? I mean, we all know service technicians nowadays, especially in our area, are very limited. Is it something to be considered, or is it something that we're still on the safe side at the moment?
From my point of view, we still need to train a lot of service technicians better. Even if they got training in the past, they still need to get more and more trainings, because they will work more on these kind of refrigerants like CO2, R290 and so on in the future, because this is the future due to as you mentioned, F-gas regulation, PFAS, that is most probably coming. So to train your service technician is the key factor for the future for sure.
Okay. So when we think about just generic refrigeration system, there's always waste heat that we produce within the refrigeration circuits. Now, is there a possibility to reuse that heat that we're actually otherwise would be throwing out of the window?
Yeah, you said it a good way. I think in the past we were used to just throw it out in the ambient air.
Mhm.
It's basically free energy which you can use, and because of the high temperatures which we have, because of the refrigerant, this is free energy which you can directly use, depending on your heating system, of course. But it's basically with a few extra components you can use it in your heating system. So
Okay.
Yeah.
Maybe I can add something.
Yeah, go ahead.
The great thing is for CO2 as a refrigerant, you have a very high discharge temperature. So this means you can not only use it for concrete heating or something, you can also use it for the indoor units to heat the shop area, for example. And you can even use it for domestic water.
Okay.
So there are different possibilities for heat recovery.
When I think about connecting the refrigeration system to the heating system in a building, do I need to have any additional heat pumps, or is the waste heat actually sufficient to really heat the whole building?
This always depends on the cooling system, how much energy or how much waste heat you can produce by the number of cabinets, more or less, by the cooling capacity. So normally on a CO2 refrigeration system, you don't need to add a heat pump.
Mm-hmm.
So normally the waste heat is more than enough, but for sure it could happen if you have a very large sales area and only very few cabinets connected to the system, then you will most probably need some kind of heat pump, but this can also be connected to the CO2 system.
Okay.
Like a ghost load evaporator, for example, on the gas cooler.
Okay.
Yeah, it also depends on the heating load of your building. Typically, older buildings, they need to have a higher heating load, so it's always a bit, for every project, different.
Okay. Is there any limitation to the heating system? For example, if I have an old heating system, it's not compatible with the CO2 system, or is there always something that we can, let's say, make in between in order to connect these two systems?
Well, the trend in heating systems is basically that with the temperature for it is decreasing. But since we have those high temperatures already available with CO2, I wouldn't say there's a big limitation, because you can use it for older systems, but also for newer systems like floor heating, which require a lower temperature. So in my opinion, not.
So we also know that the installation of a remote CO2 system is quite a lot manual work. So you need to have welding on site for the pipes, you need to fill up the refrigerant. Are there any innovations or changes that makes this installation process faster and easier?
There are some, to be honest. So like condensing units, for example, there you have the compressor and the gas cooler in one unit, more or less, that you place most of the times in the outside of the building. And there you save some time in the installation part, because you don't need to weld the pipes between the compressor rack and the gas cooler. And these units come pre-configured and also pre-filled with some kind of refrigerant. Not the complete refrigerant that you need for the system, but it still saves a lot of time for installation.
So there's still a big group of shop owners out there that are a bit afraid of remote CO2 systems. What kind of measures do we actually have in place to make them feel more comfortable, for example, and take away that fear?
Yeah. Well, first of all, sensors, of course. We in our safety concepts we install sensors. An example for me is a cold room, that because it's a relatively small room, and if there's a leakage, then it can go wrong faster. So sensors, and together with the monitoring system, that you can be warned in beforehand.
Okay.
But also for me, a thing is that there are more and more installations out there. In Europe, already more than 100,000. This means that the technicians get more and more used to the systems, and also the technicians we send to the sites, they're skilled. Okay. So they know what they're doing. So yeah.
Thank you guys for your time and your explanations. If you have any questions, feel free to reach out. In the next episode, we will cover two major topics, which is subcooling and superheat, also related to remote CO2 refrigeration. So stay tuned. Thank you and bye-bye.